Okay, folks, this is another installment. Give me a second here. Get myself set up. Hope everybody had a good holiday if you celebrate the holidays. Um, Give me a second here, and I am going to get my people in here. If you don't know, every Saturday and Sunday Saturday and Sunday evenings, we do a group session, and we're going to get this underway. So if you are preparing for the Astbe, Afoqt, Sift, or Asvab, this is the channel or the place to be. If you want to see the specific questions that we're going to present, you can follow me on Facebook. All the questions will be on my page on Facebook. Just look up STEM with Kino on Facebook, and you can actually see the questions that we'll be executing today. Ready. So I'll start pulling my guys in. Dylan, how are you, sir?
I'm doing good. And yourself?
Not bad, not bad. Give me a second.
How was your Christmas?
It was good. I cannot complain.
That's good.
Can't complain. What have you been working on, sir?
I was working on this worksheet. So, like recently, my biggest thing is this. I want to get more into geometry, just to geometric sequence, get more familiar with it.
Okay.
So I was going through the timeline as well. Let me just pull this up. So, like a little bit of fractions, ratio and proportion as well. Just being more familiar, me fluent with it.
Okay.
I've been working on the most. I think I've seen a lot more improvement on is my percentages.
Awesome. And that is a very necessary skill to have.
Yeah.
And all right, you will see all the questions, but like on days that you can't make the group session, if you go to STEM with Kino on Facebook, you can see all the questions that we discuss.
Okay. We want exponents too. Let's we get some practice on that if we have time.
Yeah. We will have time. Okay. Just waiting for a few more folks to come in.
Okay.
Hello.
Hey, how are you doing? Is that Kara?
Hello.
All right. Kara, meet Dylan. Dylan,
Hello.
meet Kara.
Nice to meet you.
Hi, how are you?
Good.
Okay, we will be underway here in a moment. So, Kara, how have you been? Happy holidays.
Same to you.
Okay. Okay, so we have one more holiday to get through. That's New Year's, and
Oh yeah.
I hope you guys conduct yourselves safely. A lot of nuts out during the holidays.
Yeah, I'll probably. Yeah.
Alrighty. Okay, Dylan's here, Chris here. Who else is here? I think that's Sharona. Sharona, is that
Yes,
you?
I'm here.
Hi, happy holidays, dear.
Same with you guys. I hope
Okay.
it was good.
Yeah, it was good. Good food, family, and good friends. So, all right. So here we go. So I will basically what I'll do is I'm just gonna bounce around. I'm gonna just touch on just particular subjects because you've all been doing your personal studying, or you've been going through your test prep books, and you may have come into contact with things that you didn't understand or you can't answer quickly. The primary focus should be on math. Okay, math is really a big point scorer. I don't know if that's even a correct phrase, but you want to be very strong in math if you want to do well on any of these exams, whether it be the ASDBE, OAR, AFOQT, Asvab, or Sift. Your math game has to be tight. So, again, we do this group every Saturday and Sunday, 5:30 to 7:30, and let's jump in. Dylan, we'll start with you first.
Okay. Do it.
So talk to me. What are some issues you're having, sir?
Okay. All right. So I want to start off with we can start off with some exponents.
Okay, exponents. Very
Exponent
well.
problems.
Okay, exponents could pop up on every test.
Yeah.
Your easier ones, and I'm going to drop an image on the timeline, and we will let so you guys all can see. And I have to drop this image on stemwithkino.com as well. And excuse me, I'm on the back end of a cold. No worries. Okay, so your simplest exponents can come in from like this. Like number one, we have 2m to the second power times 2m to the third. This is like your very most basic that you find on the test. Now there are some more advanced ones, but we're going to start with low end, middle, and then we'll go to like the very hard or the hardest type of exponent problems that you guys can run into. So what I do is I focus on the numbers, then I focus on the bases and exponents. So Dylan, what is 2 times 2?
4.
Okay, so 2 times 2 is 4. And then now we're going to deal with the bases and the exponents. So what do we do in this configuration when we have multiplication going on and there's no parentheses and we're multiplying the bases and exponents?
We add.
We add, very good. So this will be 4m to the 5th. And if anybody didn't get that or they didn't understand it or if that doesn't make sense, please stop me now. Okay, and if I don't hear anything, then I'm assuming we're good to go. Okay. A mid-level type problem would be something like this, where we would have 4 a cubed b squared times 3a to the negative 4th, and then b to the negative 3rd. Again, when you look at this problem, focus on numbers, base exponent, base exponent. So I'll deal with the numbers first, then I'll deal with the a's, and then I'll deal with the b's. All right. So, Sharona,
Yes, sir.
where are you? There you go. I hear you. Okay, so we're going to deal with the numbers, the bases, and exponents. So if we do the numbers, what are we going to multiply? 4 times 3, right?
Yes, sir.
And that's going to give us 12, right?
Yes, sir.
And now, when we deal with a to the 3rd times a to the negative 4th, what would be the answer to that?
It will be a to the 3rd over negative 4.
No, ma'am.
No.
What you're looking at, I'm sorry, I keep coughing. You're looking at a to the 3rd plus negative 4. Because we add the exponents.
So you
So,
wouldn't flip and put that 4 at the bottom.
well, no, we're not going to do that yet. We have to take care of the multiplication first. So, if we added 3 plus a negative 4, then what will we have? What would we be left with?
You have a negative 1.
Negative 1, okay. Now, we can't have a negative 1 in our final answer, but don't worry about that.
Okay.
This is the way I want you to process it. The numbers, then the A's,
Okay.
then the B's. Kira, where are you, dear?
I'm here.
All right. So if we have our exponents that we're dealing with, we have b to the 2nd plus negative 3. What will be the result?
B to the negative 1.
B to the negative 1. Okay, so now this is not finished because we cannot have negative exponents in our final answer. Can't have that. So Dylan, we have two bad children, don't we?
Yes.
Okay, and what do we do with the bad kids?
We take them downstairs.
They go downstairs, and then what happens to their attitudes?
The attitudes. They go upstairs. Or?
No, they're already upstairs. So the bad children go downstairs, and they change their attitude. So they're not negative ones; they're positive ones now. So the final answer is 12 over AB. Okay, everybody got that?
Yeah.
Yes, sir.
Okay. Very good. All right, let's come in with another slide. We're going to talk about the power of a power rule. All right, and I'm going to display this in the next image that you guys see. And this will also be on the Facebook page, STEM with Kino. Okay, so question number 11 is what I want to focus on. Now, Dylan, if we raise anything to the 0 power, what is the result going to be?
It'll be 0. Well, it'll result as a 0.
No, it'll be 1. Anything raised to the 0 power is 1.
1. Okay.
All right. So the 0 deals with everything in the container. All right. Kira and Sharona, you see that?
Yes, sir.
Yes.
So the answer is 1. No matter what's in this container, if there's a 0 out here, and this is the power of a power rule, it's going to deal with everything in the container, and everything is going to be equal to 1. All right. You guys should have question number 12. We'll move on to question number 12. And we have 2x squared to the negative fourth. All right. Now, what we have to understand, in the power over power, the negative 4 attaches to everything in the container. Everything in the container. So, this is the way I visualize it. 2 to negative 4, and then x multiplication to the negative 8th. Are you guys good with that so far? All right.
Yes, sir.
Okay, outstanding. Okay, so now we have 2 bad kids and they must go downstairs. So we have 1 over 2 to the 4th, x to the 8th power. But this is not finished yet because we have to resolve this. All right, 2 to the 4th power, which is 2 times 2 times 2 times 2 times 2. And that makes that 1 over 16, x to the 8th power. All right. Does that make sense to everybody? And if I don't hear anything,
Yes, sir.
I assume you guys are good.
Yes, yes,
Okay.
yes. Mhm.
All right. Very good. Okay. So that was exponents. All right. All right, Sharona,
Yes, sir.
talk to me about a topic you've been studying and it's been giving you issues this week.
Okay, I've been working on the radicals, adding and dividing and multiplying, and I came across one problem in particular I'm still confused about. So I'm about to put it in the group and then send you the answer in your personal chat.
Okay. Well, if you send it to me in the group, it's fine. I'll see it when you display it. So
Okay.
just save yourself some work.
Okay. Okay, do you mind if I say it? Because I don't have squares on my keyboard. I'm on my phone.
Okay, no problem.
Okay, so it's the negative 3 and the square root of 7r cubed times 6 and the square root of 7r squared.
6 and the square root of 7r squared. Okay, can you see it on the board? Can you see it on the board?
Yes, sir.
I just want to make sure it's right. Okay, so again, I'll focus on the numbers, then I'll get to the square roots and then the exponents. And I don't change the way I attack this math. I do it, I'm very or structured the way I do things because I know how easy it is to get into a situation. So I recommend you do it like this. Focus on the numbers first. What is negative 3 times 6?
Negative 18.
Negative 18. All right, we'll put that to the side. That's going to be a part of our answer. When we have a number and the square root, like if I had like the square root of 6 times the square root of 6, in my head, the square root just flies off and it just becomes a number. So in this case, the 7 just comes out because that's root 7 times root 7. But we have to multiply that, all right? And then we're left with the square root of r to the 5th power, because r to the 3rd times r to the 2nd will be r to the 5th in basic multiplication. So now we have to resolve. Simplifying. Well, we got to multiply this, so let's do that first. 18 times 7. That'll be negative 126. And then r squared r. So 2 out, 1 in.
Yeah.
All right.
Okay.
So negative 126 r squared root r is the answer to the problem. Excuse me. Any questions?
For r squared root r, is that just from you breaking it down to
Yes.
square root of r4, which is r2, and then the r left behind?
Mm-hmm.
Okay.
All right. And then what I'll do is a little quick breakdown for you guys. And Sharon, are you okay with this problem?
Yes, sir. I saw my mistake. Thank you.
Okay, outstanding. Good job. All right. So here's the thing: when you have variables and exponents under square roots, I look at it like this. Fourth, r to the fifth. Okay, so we have to remember that a square root is 2. There's a 2 associated with the square root. Something is multiplied or multiplied by itself, and it becomes that number under the radical sign. All right, so when I'm simplifying these, I'm looking at what can pay its $2 to get out. That's how I look at it. So with the square root of r, the answer is just square root r. It didn't have 2 to come out. All right, now if I have r squared, then the answer is r. It jumps out, it pays its 2, and it comes out. The rule I have for 3 is 1 in, 1 out. And what I mean by that is one r is going to be in and one r is going to be out.
Or should be out.
So r root r. R to the 4th will pay its 2 and become just r squared. And then my memory for r to the 5th is 2 out, 1 in. So it will be r squared root r. 2 out, 1 in. And make sure you guys write that down, because this is if you know a lot of people, and you got to understand when you take this test, you guys are going to be rated against the other people that took the test that month. Okay, most people will see this stuff and they will be like, "Oh my God, I don't know how to do that." So this is where you stand out ahead, and you will build points where others can't.
Mr. Chino, I have a question. So the same equation I gave you, what if it was being added or subtracted instead of multiplied? What would you do with the exponents of the r's then?
Okay, give me a second, because you know me, I have a million questions.
Okay.
Look, I'm like my aunt. You know how I get down. Okay, give me a moment here. All right.
Okay.
Let me find a really, really, really fun one. Actually, this one doesn't even have it. Just give me something, because I thought I had something in the worksheet, but the worksheet is adding and subtracting radical expressions, but it there's nothing with variables in them.
Okay, yeah, that's the only time they came in was when I was dividing and multiplying. So I don't have one with a variable.
Yeah, that's what I'm saying. Like, that's really not typical.
Yeah.
It's not typical.
Oh, okay. Because I haven't. Okay.
But I mean, if you give me something, I'll execute it. But I mean, it's really not typical. You'll see addition and subtraction like what I'm about to drop on the timeline now. Give me a sec.
Okay.
All right. You will see addition and subtraction like this, guys. This is how you would typically see it in testing.
Okay, yeah.
That's how you typically see it. So since we opened up that can of worms.
Yeah, can we go over this?
Yeah, thanks, Sharona. Hey, y'all know I don't care. I'm like, hey, whatever, you know, but you know me, I gotta be me.
Are we starting with 19 first?
Yeah.
Okay.
Yeah. All right. Okay, and again, this is on the Facebook page as well. Number 19. Okay, so when you process this, it looks a little crazy at first, but you just got to stay structured. So if we have 3 root 18 plus root 12 plus 2 root 27, I process it from right to left. All right. Now, in each one of these cases, we have a whole number outside of the radical, and they're just going to be temporarily just put to the side for a minute. And I'm going to, you know, simultaneously, while I'm doing that, I'm also going to solve the factor out the radical. So this is what I see. I see 3 root 9 root 2 plus 3 times root 4, root 3, plus 2, root 9, root 3. 9 times 2, and 9 is the hot number, or the perfect square, equals 18. 12, 4 times 3, 4 is the perfect square, equals 12, and then 9, the perfect square times 3 is equal to 27. Now, in each one of these cases, each one of these perfect squares is going to break down. So we have 3 times 3, root 2, plus 3 times 2, root 3, plus 2 times 3, root 3. There you go. So now the multiplication has to occur. And we would have 9 root 2 here, 6 root 3, and 6 root 3 again. All right, so our final answer would be 9 root 2 plus 12 root 3. And if anybody didn't get that, stop me. If anybody didn't get it.
I didn't get it. Wait 1 second. So. I didn't get it. So don't they have to be in the same family for the solution?
No, it doesn't always occur like that. I will also post on the timeline and this is the reason why I sent you guys that, because here's a solution or the answer key to those questions. So if we look at the solutions or the solution for these problems, it's not just one square root. It's you have the root 2 family and the root 3 family in this case.
Yeah.
So when you boil everything down and then you wind up with, oh, wow, we got a root 3 family, they must be added after we resolve the multiplication.
Okay.
You see it now, sir?
Yes, I do.
Awesome. Okay. You also asked about division as well, right, Sharona?
Yes, sir.
Okay. All right. Let's get this off the board. And give me a moment. I'm always juggling like 50 million screens. And okay. All right. Now, in a process of division with radicals, we have to perform an operation called rationalizing the denominator. All right. And here's the timeline is dropping. Let me take care of my Facebook people. Let's get this, all right, I dropped that there. And Okay, so let's look at the first one. Okay, so when we have a situation like this, we cannot have a radical in the bottom. We have to do something called rationalizing the denominator. And that's only just multiplying the top and the bottom by the said denominator. All right, so if I have root 15 over 5 root 20, the top and the bottom are going to be multiplied by 5 root 20, which is the denominator. That's what we call rationalizing the denominators. Okay, so with fractions, when we multiply directly across. So if we don't see anything in front of the radical, we just imagine that there's a 1 there. So 1 times 5 is 5. And 15 times 20 is root 300. 5 times 5 is 25. And anytime we multiply a square root by itself, and it's the same square root, the denominator the square root just flies off. So we good there so far, folks?
Yes, sir.
Okay, so now, this will become 500 over 5 root 300. Okay, now I'm going to simplify the 300. 5, I will use root 100 and root 3. Because the square root of 100 times the square root of 3 is the square root of 300. And that will be over 500. And then this will become a 10. 5 times 10 is 50. So we have 50 root 3 over 500. But this fraction, 50 over 500, must be broken down. So initially I can go bang like that. And 1 tenth. So it will be 1 tenth. But the way it would look like on a computer is like this, because 1 times root 3 is root 3. So the final answer will be root 3 over 10.
Okay, I have a question.
Go ahead, I'm listening.
So the way you did it, is that standard? You have to do it that way?
Not always, but this is what I want you to learn, because this is how you properly rationalize the denominator. Sometimes you can take shortcuts, but I would rather you learn it this way. And I know it seems like a lot, but the more you do it, the faster you're going to get. And if you want more problems, you can just type in your Google and your search engine, whether you use Yahoo, Google, whatever, dividing radical expressions, hyphen, questions and answers, hyphen, PDF. And it will create hundreds of worksheets for you.
Okay, because when you were doing it, I got a little nervous. I thought I did it wrong. I got the same answer you did, just from the beginning, I left the 15 under the radical, and then for the bottom, I just did 5 times radical 4 times radical 5, and then what did I do? Yeah, I broke down to 15, radical 3 times radical 5, 5 times radical 4, radical 5, canceled out both radical 5 from top and bottom, and then square root of 4 is 2, and I got the radical 3 over 10.
Okay, but there's more than one way to skin a cat, mathematically. Like, let's say, I'll give you an example.
Okay.
Tell me how you would solve this. What would you do?
Oh yeah, for that one you go for the common denominator, which is 4.
Okay, so tell me what your next step is.
It'll be, well, I will break it apart and have it like in a column. So it'll be 1/2 equals 4 on the bottom, and then times by 2, so it'll be 2/4. So 1/2 equals 2/4 plus 3.
Okay, so
Yeah.
you would have it situated like this: 2/4 over 3/4, maybe something like that.
Yeah, like more the 2/4, it'll be the 1/2 first, and then I would go to the right and put up a 4 on the bottom, cross multiply whatever the bottom to the top. So then I would have the 2/4 plus 3/4, right? And then it'll go 5/4, it'll be 1 1/4.
5/4 or 1 1 1/4. Me, what I would do is 4 times 1 is 4 plus 2 times 3 is 6. And then 2 times 4 is 8. So I would have 10/8, which if you reduce that fraction, it'll be 5/4 or 1 1/4. So we just did the same math problem 2 different ways.
Okay.
So what I'm saying, this is not this is the structured way that I want you guys to learn how to do these radicals. Okay. But there's more than this. My way. My ways are very efficient because I teach, so you can have time to spare. That's why I teach my math, because time is your worst enemy. So no, that's not like the only way. All right. Okay.
Yes, thank you.
You're welcome. Okay. We have 8/100, and Sharona, you're gonna take the lead on this, dear. So,
Okay.
what is the first thing we need to do?
Rationalize the denominator.
Okay. How are we gonna do that?
Multiply the top and the bottom by the square of 100.
Mm-hmm. Okay.
Alright, then I get the square root of 8 times the square root of 100 over 100.
Okay. Or I would just multiply root 800 over 100 because the 200s multiply and the radical flies off.
Okay.
So now what do I do next?
I break it down. I get basically 10 in the square root of 8 over 100.
You said 10 times the square root of 8?
Yes, sir. Because 100 breaks down to 10.
Mm-hmm. Okay. So, that breaks down to 10. All right. So that came from the square root of 8 times the square root of 100? Is that what you're telling me?
Yes, sir.
Over 100?
Yes, sir.
Okay. So this is going to become a 10.
Yes, sir.
Now, but does that break down or no?
Yeah, it breaks down to more.
Okay. Talk to me.
So it'll end. My final answer is the square root of 8 over 10. Well, no, my final answer is actually, hold on. Uh, 20 in the square root of 2 over 100, and then you divide.
20 root 2?
Yes, sir.
20 root 2. That's interesting. All right.
Because I break down the, okay. I break down the.
And I'm not saying you're wrong. I'm just okay. So I see 20 root 2 as well. I'm not saying you're wrong. I'm just asking.
I'm all over the place. That's how
It's okay.
And then you just break it down, so I end up getting root 2 over, yes. Oh, I thought she said it, root 2 over 5.
Root 2 over 5 is the correct answer.
Yeah.
Yeah, root 2 over 5 is the correct answer. Because this fraction is basically 1/5. But 1 times root 2 is root 2, so root 2 over 5 is the final answer.
Is that too confusing of a way to do it?
No.
Because I know it's time saving as well.
No, you were pretty efficient. I was just asking questions, and I do it step by step by step, but mentally you jumped ahead, which is not bad. That's not bad.
Okay.
But I have to do it the style that I have to present it is not just for you, it's for everybody, or so.
Okay.
But no, you didn't do anything wrong.
Okay.
Okay. So are you comfortable with that, rationalizing the denominators?
Yes, sir.
All right, very good, very good. Kira.
Yes.
How are you, dear?
Good.
I'm sure you ran across something that you just did not understand, didn't make sense, looked like Chinese to you.
Yes, I'll post it. Here you go.
All right. Don't worry about multiple choice questions. I've seen this before. All right, so let me drop this. I'm gonna take this and okay, the question reads as follows. A blueprint has a scale of 3 feet per half inch. So that means that on the scale on paper, 3 feet is going to be represented by every 1/2 of inch, 1/2 inch on the paper. um, I'm sorry, I got distracted by. All right. So the question reads as follows. I'm switching screens and it's just lagging a little bit. Bear with me, guys. Okay, a blueprint has a scale of 3 feet per half inch. So when they give you that, this is the standard that they're giving you. Every 1/2 inch is going to be equal to 3 feet in real life. You know, if I had the scale of my bathroom on this particular sheet and this was a blueprint, we can have a real 3 feet. It'd be 3 feet of paper. The paper would be the size of the bathroom. So this is how we scale down. So we'll say, well, 1/2 inch measured on a piece of paper is equal to 3 real feet of the bathroom. So the bathroom's measurement is 1.5 inch by 2 inches on the paper. All right, I'll write that out. 1.5 inch by 2 inches. So you could do this. You can use, there's a couple ways you could do this. But if I understand that 3 feet is equal to 1/2 inch, and I have 1.5 inches, this is 9 feet. Because a half, 3 feet, plus a half, 3 feet, plus another half, another 3 feet is 9 inches. And then a half times a half times a half times a half is, well, plus a half plus a half plus a half is going to be actually 12 feet. So the actual dimensions of the bathroom will be 9 feet by 12 inches.
Okay, can you go through it one more time?
Sorry. Okay. This is the standard. 1/2 inch equals 3 feet. So if I have 1.5 inches, there's 2 halves in a full inch, right?
Yeah.
So that's 3 feet, that's 3 feet, and that's 3 feet. 9 feet.
Okay, yep, got it.
And then if I have 2 inches, then there's a 1/2 inch, a 1/2 inch, a 1/2 inch, and a 1/2 inch in 2 inches. 3, 3, 3, 3. 3, 6, 9, 12 feet.
Got it, okay.
Okay. Dylan, what do you have for me, sir?
Can we go over? Okay, let's go through my thing where I need to go. Geometry.
Okay. There's a lot of areas of geometry. What would you like to?
Like volume of like a cylinder or cube or diameter stuff. Circular or circle. Find out find out the
Okay, so
area.
you want to do volume of geometric shapes?
Yes.
Okay. All right. Give me a second. Volume of geometric shape exercises. Okay. Okay. We'll even go even two-dimensional. So we'll start two-dimensional. All right. So let's talk about area perimeter as well, since we're on the subject. Okay. So, Dylan, what is the area of a square?
Length times width.
Very good. Length times width. So if this if one side of this was 100 feet, if one side was 100 feet, what would be the area?
The area would be 1,000 feet.
I'd like you to multiply 100 times 100, and I promise you'll come up with a different answer. Don't do math in your head. That's the easiest way to crash and burn on this test.
10,000 feet.
10,000 feet. So that is the square area of this object. All right. Sharona, what would be the perimeter of this particular shape?
It's going to be 2L plus 2W.
Okay, I'll take that. I just want the answer.
I'm sorry.
Like, yeah, you got the formula, but what's the answer, man?
400.
400, very good. All right. Kira, I know you're new, but never ever laugh at my artwork. Okay, that's rule number one. What is the formula for the circumference of a circle?
Is that one pi r squared?
No, that would be area. But thanks.
C equals. Hold on, let me look at my notes.
And this is common knowledge you guys will need to have. Seriously, like, without even thinking about it, put it down on, 3x5 note cards. Do whatever you have to do. But yeah, this is
Four pi r squared?
4 pi r squared. All right, I've installed an image onto the time. And if you go to the bottom left, you see the formulas for area and circumference.
2 pi r, okay.
2 pi r. So that is the formula for circumference, and you gave us area. Okay. The way I remember it like this. I remember when I was in school, right? You see 2 pi r for circumference. So when I want to say, okay, well, what's area? I say that the 2 jumps on top of the r. See that? So you got 2 pi r, and then if 2 jumped on top of the r, it'd be pi r squared, like that. That's the memory aid when I'm trying to differentiate between circumference and area. Makes sense?
Yes.
Okay, I want each and every one of you guys to execute these 4 problems, and then I want you guys to type your answers in on the timeline. And I just want to make sure everybody can see the image on the timeline.
Yeah, yes, sir.
Okay, let's execute all 4 of these problems. Type in your answers. Okay, ladies and gentlemen. So yeah, we have like another hour to go in this session. So we're here every Saturday and Sunday, 5:30 to 7:30 Eastern time. So no matter what your schedules are, you should be able to follow it. All the questions are posted on my Facebook page, which is stemwithkino.com. Stemwithkino.com on Facebook. Please follow and like the page and stuff. But I'm going to continue on with the class. This was really just kind of like a sample of what happens in the group sessions. Basically, my clients, some of them meet with me once a week. Some just come to the group sessions depending on their schedules. And basically, I assign what I call prescriptions, which are basically questions that they will likely find on the aviation, on Asvab, Afoqt, Sift, OAR, and basically this is where they tell me, okay, well, I've ran into problems with this, I've ran into problems with that, and everything. So yeah, it's a very effective tool. But I'm here every Saturday and Sunday for 2 hours, 5:30 to 7:30 Eastern, and what else did I want to say? So yeah, if you guys are interested in joining the session, which I do highly, highly recommend, because most people are not prepared for this test. Well, some might be for the Asvab, but not the Afoqt, not the Astbe, OAR, and the Sift. Most people are not prepared. And so it doesn't have to be me, but just find a qualified tutor with a proven track record. That's really, really important. So that's all I have for right now. I thank you guys for watching. I will see you guys next week. Take care. And hit me up on Facebook, stemwithkino.com, if you guys want to be included in the group session. Highly recommend it. Happy holidays.